Hi everyone, Quinn here. As you know, I've been spending most of my time working on Rhizome. I've made a ton of progress this week though, so I spent some time today and yesterday putting together a small demo of where things are at. I want to stress though that things are still early, and there's a lot of critical features like content addressing that haven't been implemented yet. And I also have not been prioritizing performance whatsoever. There's still a lot of work to be done, but let's see what it looks like. Here I've got 3 different browsers open, all to a small app that I wrote using the web native app template. In each case, I'm logged into a different user, each with their own file system, and with none of those users having been linked using device linking. In each app, we can see the username of the logged in user at the top. We can see the stars that they're connected to. That'll be relevant later. And then at the bottom, we have a small to-do app. It works just like you'd expect. I can create a list, say grocery, and then I can start adding items to it, eggs and milk. On its own, that's not super interesting. And this is already something that you can do using Web Native. Where Rhizome comes in is in supporting multi-user and multi-app collaboration. Here's what that looks like. Over in this side, or over in the second and third browser, you'll see that this second browser is actually connected to 2 other stores. One of those has the same name as the user over here. I've actually set up a link or a symlink between the second user's file system and the third's, so that any writes that the third user does will eventually propagate over to the second user. For example, if over here I make a new list called work, that'll show up on the left. Then I can add a few more items to it, like paint fence, go shopping, and do dishes. This only works in one direction though. If the second user here says that they painted the fence, the third user is not going to see anything. And that's because only the second user has subscribed to the third user's data. That's not a problem though. And because data log is largely monotonic, we end up with eventually consistent queries. So if I take that second user's username, and then I subscribe to them over in this third user's browser, we are eventually going to end up in the same state. There we go. It sometimes takes some time to synchronize, especially if IPFS is going slow. But the key point now is that because we have the symlink set up between both file systems, we're using IPFS as a persistence layer, and so we're able to collaborate between offline peers over long periods of time. Now we're in a situation where we can start marking things as done and so on in either of these browsers, and it's going to propagate over to the others. Also helpful is that because we have all of this living in IPFS, we're now able to later refresh the page, wait for things to resolve again, and we will end up in the same state. And also, because data log is largely monotonic, we are able to continue unioning all of these different stores together and just eventually bring everything in line with each other so that everything eventually converges. Once all of these resolve, we're essentially going to end up with 3 different browsers that are spread between 3 different users that are going to have a consistent view into the state of this to-do app. And there we go. I'm not controlling the ordering in any way right now in the output, so things are rendering in slightly different orders, but they're all in the same state. And now as we mark things off in any of these browsers, it's going to propagate off to the others. This is a pretty simple example, but it shows off a lot of the flexibility that I've been building toward with Rhizome. You have to remember that Rhizome is actually implemented as a Rust library, but then I'm compiling that down to WebAssembly. We don't only want to support WebAssembly though, and so I spent a lot of time understanding the Rust ecosystem and how asynchronous Rust works and how all of the different pieces of the ecosystem tie together to support asynchronous Rust, both across WASM and across native deployments. And so I actually have all this running on the desktop too. I have another crate that uses Rhizome as part of, alongside a Tokyo runtime to actually run queries over streams of facts that come in over sockets and WebSockets, for example. And the The reason we're able to see things synchronizing so quickly between these browsers, like if I create a new list over here, it immediately shows up over here, and then I can say foo and bar and start marking things off, is because I actually have all this running on the back end too, as a native Rust app, uh, ingesting all these facts in over a WebSocket, and then propagating them outwards to any of the other connected peers who are subscribed to the store associated with the user who wrote that fact. That's what allows us to essentially do real-time collaboration uh, despite WinFS typically relying on DNS updates. Essentially, we can use quicker side channels like WebSockets for online peers, but then rely on IPFS for offline usage. And the end result is that we are able to persist everything we care about and run eventually consistent queries over the